All right, welcome everyone. Let's see if it kicks in. There we go. Yeah. Welcome everyone to this online edition of ProductTank. We are currently still waiting for people to join. We've got 9 people already waiting, and feel free if you already can see the chat. Feel free to write us some notes. Maybe where you're from, where you're streaming from, and any question that you might have for the topics. And we already have Florian and David today. We'll just give it another minute until we kick it off. All right. So while we're waiting, there you go, Stockholm. Welcome, Isaac. David, tell me what's been going on big language models. I saw that in the description, was curious because I at least from what we've discussed in the past, right, and what we've worked on, it seemed like you were already deep into that rabbit hole.
Well, of course, you will see that, but what I can tell you already in advance that single user as you or me, it's somewhat different than the actual industrial productive use. And that's what I'm going to show you, what's the difference and how we actually should consider large language models in an industrial setting. So that's what I'm going to tell you in a few minutes, I would say.
Sounds good. Sounds good. And Florian, I saw windsurfing. I know we discussed about this, and I'm not sure if you mentioned or somebody else mentioned that they had an app. It was actually a funny coincidence. I had a workshop a few weeks ago, and they told me that they asked the whole group, like, what's your most relevant apps if you could keep only 1 or 2 apps. And the trainer actually told me that they had a person, they had a windsurfing, a wind app, just so that they could know when they could go windsurfing. Is that, yeah. Do you have such an app as well?
I have 2 even.
2, all right. I don't know.
Windfinder and Windguru, and I tend to select the one which gives me the better forecast.
Is that a subjective thing? Like, I don't like the weather you're showing me, so I'm gonna look at the other app, or is there a way to?
Yeah, it's usually, you're planning a vacation, you're booking everything, and of course you have no idea how the weather is going to be like. So the closer the time gets, you get on the water, the more often you look at the forecast, and then I compare forecasts and think about, okay, well, this doesn't show me any wind, but this one does, so I'm sure the other one must be right. So this is roughly how it goes.
Understood. I thought you were doing it like me, where I look at 2 weather forecasts and I'll just choose the one that says it's a better weather, like sun. But both apps show the same thing. So. Good. All right. We have quite a few people already in, so we're going to kick it off. Welcome everyone to another ProductTank edition. As mentioned in our previous in-person one, we continue with the same topic, and this is because Florian and David also reached out to me at the time when we when we had a call for speakers, and we had quite interesting discussions. And I think what they're going to present is quite interesting and brings new perspectives in the mix of using Gen AI in products. And I'm gonna talk a bit and refresh a bit what ProductTank and Mind the Product is about, and after that we're gonna jump straight into the talks and have David with the first presentation. Since we're using StreamYard and doing live streaming on YouTube, you're not going to be able to join with voice for the questions, so please write your questions in the chat, in comments, even during the talk, and I'm going to gather them, and at the end we're going to ask both David and Florian after their presentations the questions. Yeah, happy to have you. Let's kick it off. If you haven't attended ProductTank before, any ProductTank edition, which is it's starting to become something increasingly difficult to achieve, We are the world's largest product community. There's a lot of meetups online that take place. It started in London with Mind the Product and Mind the Gap, right? Mind the Product conference, and then expanded with online meetups all around the world. And I think there's over 200, well over 200 meetups right now everywhere. And yes, ProductTank is the community that's built by each local community and group. And then we have Mind the Product, which is the global professional network that you can also check out, and definitely check out mindtheproduct.com. And you can get involved in the community. We've mentioned this, and if any of the people who've already reached out are in, I apologize for the delay in replying. We have seen your call for either speaking or for hosting the meetup, and we will get back to you. But this is the way that you can get involved. We are looking for venues all the time and for topics that are interesting for said venues and companies, and we bring the community to you. So if you want to host or sponsor ProductTank, do get in touch. LinkedIn, Meetup, whatever works. You can also speak at ProductTank. You don't need to have gone through a speech writing or a speech giving course or any kind of thing like that. We're all kind of like, we're people that don't regularly give speeches. We're more like people that do great work with our teams. But if you have something that is worth sharing and you feel like, hey, I want to connect with the product management community and I have something that I want to kind of talk to them about, please do get in touch. And of course, you can write for mindtheproduct.com. They're always taking call for articles. And you can also become a member and get more content from a lot of experienced product managers and leaders around the world. This is the team, and this is us, co-organizers. We're going to have a call later this year also for new co-organizers. We're trying to kind of distribute the work and have it so that we get 1 or 2 people that or each organize one event and get to maybe 4 to 6 events per year. This hasn't yet gone the way we wanted. Apparently, a day-to-day work and busyness somehow gets in the way. We're working on that. And that brings us to today's topic, using generative AI in actual products. And we have 2 amazing speakers today that will share, that we're open to share with us what they've been working on and how it's working for them. And the first speaker will be David Zibriczky. He's a senior data scientist from DB Schenker. He is leading a team of data scientists there and working on a lot of interesting things. And I cannot wait to see how they've been applying Gen AI into their products and how it's making it useful. And of course, also connecting it to the value, right? And direct value for users and indirect value for the company. And we have also Florian, and I won't skip to his slide. Florian actually founded his own startup on location and places analytics, and it's quite an interesting topic that spans several industries. What he's generating right now, and the product and what the things that he's created with place analytics, and so he'll be talking about that later tonight. But first, let's have David present and talk to us about automated document processing with large language models. David, you have the stage.
Thank you very much, Alex. Do you see my slide, but I'm currently sharing?
Yes.
Oh, good. Okay. So first of all, Alex, thank you so much for inviting me to this meetup. It's an honor to me that I can present what we are working on in these days at DB Schenker. My name is David Zibriczky. As Alex already told, I'm working in the field of data science and AI, leading various teams and various projects. And one of the domains I really dig deep into is the large language models. And a team called GPT Squad is currently working on that under my supervision. And I'm also acting as a kind of product manager in that function, I would say, so that try to give some insights from the product perspective in this talk. So the focus is on large language models and in logistics, actually. So today I'm going to introduce a bit the logistics and large language models. Then I will focus on the information extraction use cases and also introduce the processing platform, the product actually we developed, and also some compliance topics, questions around this product in the company, and then a conclusion, and then a Q&A for a couple of minutes at the end. So let's start with the intro. DB Schenker is a logistics company, one of the biggest in Europe and also globally. The headquarters is in Essen. And actually that's that's a pretty large organization focusing on air freight, ocean freight, land transportation, and warehousing. A lot of customers we have, we do the transportation. We work with carriers who do the transportation for us, and we manage the whole supply chain, basically. And yeah, this is a logistic setup, pretty like a physical world, and it has a lot of challenges, but also opportunities for digitalization and technology. So generative AI, as already you heard that it's a pretty big thing, explosion last year already. And from this study, McKinsey thinks that that's a lot of economic impact of generative AI applications, beginning from a textual generative solution to videos, images, audio, and other modality, especially in software engineering, also customer operations, sales, marketing, products, and R&D. There's a huge potential value what we can see and we can find with this technology. When you think about generative AI, the first thing what was very popular and well known is ChatGPT. This is basically a large language model trained on the diverse, vast textual data over the internet. It is able to understand, process various languages, and understand the content inside. It's also able to capture the context of the text. So where was the text written, and what the topic is about, and how this should be understood in that that context. Yeah. And it's able to generate human-like responses. You can chat with it. It's an interactive tool. The training of ChatGPT by OpenAI is a super expensive procedure, and one should know about that. There's a knowledge cutoff over time. So it was trained at a certain time, and there was not additional training. So it contains a lot of knowledge, a lot of cognitive and linguistic knowledge, but the domain knowledge, I would say, limited to a certain time. And one thing that will be important for us is called hallucination. It's basically an error in the system on the answers that actually not correct or not completely covering the facts, and that's something we have to take care of in this context as well. So ChatGPT itself, it's a very versatile engine. You can chat with it. It can generate code. It can generate various translation text. It can also write poems. You can ask about history. You can write a blog article, and so this is super nice for a single user. You can do a lot of things with that, but then it raises the question that, is it valuable for an industrial environment? How we can exploit the features of ChatGPT and of also the other large language models in a large-scale environment? How we can scale it up, this solution? What we can do with that? That's the main question that we really wanted to answer when we started investigating this technology. And before ChatGPT, the digitalization and the intelligence for processing documents was the OCR, optical character recognition. We basically parsed, scanned various documents from the physical paper to digital ones, and we managed to process them afterwards. But there was no real intelligence, real natural language understanding afterwards, and there was a missing technology that we couldn't exploit some years back. But with the rise of large language models, GPT and others, we actually managed to uncover and identify 6 main application areas in the industrial setting, and that's what I'm going to tell you now. The first one is called information extraction. The point here is that you have document or documents, and you would like to extract key information from that. The information that you're interested, depending on the context, depending on the use of that documents, you don't necessarily need a whole 100-page document. You just need some key information from that. And that can be a lot of documents, beginning from contracts, invoices, emails, and many more that I'm going to introduce later. The second category is called assisted reading. It's basically you have a document, you have chat interface, and you can basically ask questions. You can ask about the document, where to find this and that, and how would it summarize the document or some parts of the document. Let's say, what is the summary of an email? What is the summary of the contract? Is it in this contract or not? And so on and so forth. So this is an interactive single document reading concept. The third one is called content generation. This is more well known for us. It's basically asking GPT and other language models to generate new content for marketing, for example, or even code, and so on and so forth. So you give a short prompt to define the problem, and it generates kind of output and code text that is useful for you afterwards. The fourth one is called text summarization. It's basically reducing the length of documents, summarizing them, or even generate FAQs, which is basically a kind of essence of many documents, let's say thousands of documents. If you don't want to read them, FAQs could be generated out of them using these language models. The document comparison is the fifth one. It's basically you have two documents. Let's say you have a legal document, a contract, and there's a draft or there's a guidance how to write a contract. You can check or validate against the reference document whether your document is correct or not. So this is used to compare two documents, to data sources, two or multiple inputs. So GPT has the capabilities to compare, understand the meaning of text, and understand the semantics of that. I'm going to show you an example for that as well, just for the sake of interest. And last but not least, the research and brainstorming. GPT has cognitive skills to reason, to understand the problem, and together with you figure out a solution. Let's say how to cook carbonara, or if you want to replace some ingredients, how to do that, how to make it even tastier or so. So it's a kind of interactive brainstorming about a problem, and it has a pretty good skills to do that. Okay, so this is basically the direction, what we identified as real use cases and demands from the business and from our colleagues. I talked to dozens of our colleagues. But today we are going to focus on the information extraction use cases, because we found that these are the majority of the use cases where we actually find a lot of business value. So let's say in the center we have information extraction. The challenge, the problem here, that we have huge number of documents at Schenker, thousands, 10,000s of documents, which should be processed manually most of the time, and there's a pretty large staff for various business units to do this kind of processing job. And the paper, this data is processed manually most of the time, and that's a lot of work. And with digitization and automated processing, we can save a lot of time. So the LLM concept here, that first we parse the document, parse the testing documents in PDF, images, text files, various type of inputs, and then we apply the large language models to extract the key attributes, the key information from them that we are interested in. And then we use them for following task or following use. And last but not least, we would like to automate this process in a large scale. So not just for 1 or 2 or 10 documents, but thousands or 10,000s of documents, so that we could really reach a significant impact of that solution. The KPIs, how we measure how good a solution is. One is the hallucination rate. has the chatbot, sorry, the LLM extracted the right information, how often it's wrong, and whether it managed to find the information that is there. It's a really important question that the business should also understand and decide if it's a good direction, and this is acceptable. Otherwise, the solution is just not accurate enough, and that causes more work than it solves. And the users of this product or this tool can be the labor workforce, the people who actually process data to speed up their work, but also other professionals who actually want to make a use of this extracted data. And if we replace the manual work to automated work, they can access data much faster, and they can use this data more accurately. And the benefit of that is basically saving time in-house, so FTE, so that's an actual estimation. Also additional value thanks to less human error, but we have to take into the hallucination as well. And actually other work can be done thanks to the time reduction. So that can save up time and use for other tasks as well. So this is basically the value proposition of that concept. Let me give you some example just to understand how it looks like. Let's say we have a document here on the left side. That's a license document. I had to blur it out due to confidentiality. I hope that's the quality of that is not good. That's on purpose. But actually, that's a license, the original document, and there are some highlighted information here that we want to extract. The rest is not interesting for you. There's a certain structure of that document, and we want to just see what is the company name, what is the company street and house number, postal code, license number, and so forth. So this basically, the input is a document with a certain field that we want to understand and extract, and the output is a structured table, so to say. And that's what we can process afterwards much faster, much more structured way. That can go into other systems afterwards. The second case, let's say we want to understand request for quotation. The original document here, it's a kind of quotation tender document. There are a lot of different points here, like what is the general term, what is the objective of that, what is the price, what is the terms of payment. And again, we want to see in a kind of structural tabular form the key questions here, summarized in a few words or in a well-defined value set, so to say, so that we can process them much faster afterwards. And maybe the last example here, customs declaration at the border. Transportation carriers should handle in a lot of documents, what they carry, what kind of products they want to entry or bring into the country. And that's a different kind of information there that we are interested in, we want to see and find in this document. Again, purchaser name, consignee name, port of flow and of entry, port of arrival, ETA, and so on and so forth. So these are probably you get to the point, the grasp here, what we want to solve. And with different examples, wanted to show you that the versatility of this and also kind of common patterns, what's actually to be solved. And the prompt engineering itself is an interesting question because GPT requires prompts as well. So on the one hand, we feed in the document content that is extracted by OCR. And on the other hand, we field well-crafted prompts for the engine and instruct what and how to extract. Let's say we have an email for custom clearance for the sake of simplicity now. And there are a couple of tasks that GPT has to do. The first one is that read and examine the email. So delete all HTML signs, careful read and examine the email provided. So basically pre-process a bit of the content. The second thing is extract information, look for following pieces of information in the document, like consignee, purchaser, ETA, and so on. And there are some additional instructions that if it doesn't find a value, say it doesn't find, that's empty. Then organize into data to JSON format. There's a predefined format, how we would like to see the results. based on this information, we would like to also determine additional values, like what was the mode of transportation using this information that was already extracted. And then there's the final output. This is what the engine gives on the output. And basically, that's what we can use. Oh, good. An interesting feature, let's say we extract information from documents, and let's say we have a reference and we want to compare. GPT is able actually to compare information that are not the same string, but different strings, but has the same meaning. Let's say we want to compare this kind of address for the shipper, and there are different texts here, which with a string matching, is not able to say that's the same. But with GPT, it say, yes, the same meaning. And there's also reasoning why it say like, that's differences in capitalization, but actually it's the same address. So GPT is able to compare different kind of data and use for validation actually of what we extracted from documents. Good. So as mentioned, document processing is in the center. There are different kind of documents. Basically, we want to process them, extract information. So, and you can imagine there are a lot of different use cases that we explored and actually added to our long list of backlog. But actually how to solve that in a unified way. For that, we developed a so-called document processing platform. And this platform is basically solving the core problem, the core function. This is basically identify the document type. There are different layouts, so try to understand the layout and where the information are, and then extracts the information from the document, and then also tells which page how the information is, which page is the information, and then using all of these core technologies like the OCR tools, so large language models, eventually execute this pipeline. And this is what we could call a document processing platform, which is based on the top of the RPA, robotic process automation. And in order to understand it better, I show you just one architecture diagram. It's basically the two big components. One is a user-facing or an interface component, that is an input layer. In this input layer, we feed various type of documents. And then when the documents are fed in, the input file and the data sent to the backend, where first we pass with the OCR and some other tools to really extract the textual information and the structure of the document. And then this and plus additional prompts, we send to an Azure OpenAI service in this case, and we get the result, and we forward this to the front end. This is called RPA couplet. And the RPA couplet is able to be used by the users as a front end, but can be also used as an interface for an automated backend service. So basically, we hit two flies. On the one hand, it's a front end interface for users configuring the system. And when the system is configured, then we can deploy it for a productive and large scale use. And for the sake of time, I would like to skip this slide. This is just basically the pipeline that what I already explained to you. A topic that is really important, and I want to reserve a few minutes to discuss that, it's called compliance. And for the compliance, under the compliance mean that we have to deal with some data privacy, legal, copyright, and IT security questions or problems. The first one is the data privacy. The data privacy, you can understand there's an input to the system. What kind of requirements, what kind of compliance you have to stick to in order to use it without any problem or any issues from personal perspective. So basically, personal data are not allowed to use in LLM-based solutions. So my data, my addresses, for example. And we need to reduce the priority of these use cases because that can lead a lot of questions. At best case, we can anonymize the personal data if necessary. What is allowed to use is the business documents, the information about businesses and partners, and that's what we can use and we can check the types of the documents, and we need to see if really indeed containing just business-related documents for processing. But nevertheless, the business owner should approve all of the use cases, whether the input meets the requirements. The second big pillar here is called the output, the legal and copyright questions. So we talked about what we feed into the GPT. Now the question, what comes out of that? And the main concern here is that the generated content, it's unclear whether we can use it for business or not, or how, or what extent. The problem is that, let's say the GPT was trained on vast amount of information, and not all of the data owners approved that actually their information or their data can be used for training a large language model. And they may raise claims, legal claims, when they see that it was used for business purpose, and that somehow they encounter. And this is a risk for company, although less likely, but still something we have to take into account. So the general approach for us right now that we try to avoid the use cases where we generate too much text, so we don't necessarily know the reference of the text that was used for training the large language model yet. And that's why this information extraction use case, it's really fitting to this scope, because actually just returning the information that is already inside the document. So basically we don't generate additional information. Last but not least, all of the models should be approved by a data privacy and legal team. So it's not just about the input, but also what algorithm is used, and every algorithm that we use should be approved by these teams. And lastly, where to run this solution, the IT security question. All of the LLM solutions should be deployed and run in a secure and closed environment. So where we have full control on our data, it's exclusively for us, and we know what happens with the data, and it's only us who use that. And we decided to use the Microsoft Azure services and receive liability from them that we have a secure environment. And in this platform, we are allowed to use different large language models. We can also deploy open source models there, depending on the use case. But again, the platform provider should take guarantee not storing our data, and for each platform and each model, there should be an approval in order to protect us against claims and information leakage. Okay, so to sum it up, basically the disruption of large language model reached us as well. We wanted to keep up with the latest AI technologies, especially large language model. We investigated a lot of different use cases and categories, and we identified that the information extraction use cases are actually the most demanded one, the easiest to quantify from the business point of view, and it has medium complexity and actually low compliance issues. So altogether, from various aspects, that's the best business value for complexity, so to say. We developed a platform for that, and we have a couple of use cases already close to production and to be validated on large scale at this moment. And we are working on additional ones and trying to expand our product portfolio and service portfolio with that. Compliance perspective, our product should comply to data privacy, legal, and copyright. In a large company, that's a must. And our company actually conservative to do that, but that's a safe way to do in such a large organization. So that's it. This is what I wanted to share to you. Thanks for listening to me. And if you have questions, just let me know.
All right. Thank you, David. We already have a few questions, and I'll jump right to them. Before that, I'll correct my initial statement, as I'm not sure exactly what I mentioned at the start, but David is actually a director of data science and also a doctor, having written several papers on various topics related to data science and large language models. So feel free to reach out to him. He has quite a wealth of experience and knowledge, actually, both in let's say, the research side, right, and the investigative thinking, but also applying. And this is what also was great working with David in the past, right? Like you could he could execute what he imagined could be possible. Great. I have also questions, but I'll start with the questions from the chat as promised. And the first who posted the question was Vishal. I hope, I'm generally bad with names, so I hope I didn't botch the name. And the question is, documents and invoices are sometimes handwritten and difficult to interpret. How does the mode how does data extraction work for such cases? Doesn't the accuracy take a hit? I think that was a follow-up question on the same topic.
Yeah, that's a very good question. The handwritten content, indeed, they are difficult, and this is a part of the parsing, the OCR. And for OCR, we also experimented with various deep learning technologies to extend text. So it's a part of the pre-processing before GPT with unwritten text. We have mixed results, so to say, with that. So it's currently under investigation. That's true. That's a very good question. We are currently improving the deep learning-based optical character recognition solution. Sometimes the handwritten is really difficult. And in this case, what happens here, that if we see that certain fields we are not able to extract with a certain accuracy, then we say that's an out of scope and that should be checked manually. So not every field we can extract accurately, but just some fields, and that's something we have to take into account as well. That, let's say, the handwritten texts are not extracted, and that should be taken into account manually. So this is how we process this kind of cases when that's we cannot detect or recognize something. So if you are able to automate the 95% of the cases, it's enough to check the rest. The 5%, it's already a great improvement in processing time.
Understood. Thanks for that. Next question is from Mark Wegman. How did you decide to make rather than buy a ready-made solution like Sinequa?
Mm-hmm. Yeah, we had a lot of discussion on that. The problem always was raised that actually we don't want to share information. I mean, the company is pretty hesitant sharing the business documents. And there were a lot of discussions around where is it stored, how is it stored, what services were used. And eventually all of the discussion with other companies who offered large language services, the conclusion was that rather we do in-house. We didn't want to take the risk of what happens with our data and where is it hosted and so on and so forth. And they not always wanted to take the liability for that. So that was the reason why we decided to build our own solution.
All right. I think we've got time for one more question before we switch to the next talk. So I'll let you, David, to choose from the ones that are remaining. We got a few in chat from Fayaz, Max, and Isaac. You can choose. So feel free to take the one.
The first question, why GPT 3.5 being used in particular? Yeah, in some cases, we found that GPT 3.5 doesn't have significantly better accuracy. Some cases, yes. We use both GPT-4 and GPT 3.5. This is a practice that for each use case, we test which one has better. So the price of GPT-4 is like 10 times higher, and this is the price we have to take into account. I also have to tell that actually it's not that expensive using the service, but if there is not a substantial improvement, then we just use a cheap 3.5. So both are actually feasible. We use GPT-4 in many cases when it's reasonable to use. So that's what I can tell. My answer is that.
Sounds good. All right. I know everyone else that has asked questions is not going to like this, but we will stop here, as also David is a bit pressed for time. Today, once again, David, thank you for joining us today. And everyone else, feel free to reach out to David. He can write later that he's being spammed, but you shouldn't worry. Just reach out and ask the questions. And David, thanks for the awesome presentation today. And have a crazy day.
Thank you.
Moving on with the next talk, we're not going to take a break. We're going to jump directly into the talk and have bring Florian on stage. And let me just go to the slide. So Florian, I mentioned he's a founder and managing director of GeoSci. It is a startup that he founded and actually built in the last years, and I found that quite interesting. We actually met when he was starting to build GeoSci, and actually it started from something completely, at least one of the components, right? It grew into something much bigger. And currently they have an interesting application of Gen AI into what they're doing and how they're interacting with several stakeholders. And so I was super happy when Florian accepted to be on stage. And so he's going to talk to us and present about composed intelligence and AI in practice. Florian, let me just bring the slide, and I guess you can take it away. Oh,
glad to be here. Can you hear me?
Yeah, now it's good.
Okay, fantastic. So I recently saw an ad about an AI coffee machine, and according to them, the way humankind makes coffee is about to be turned on its head. Really? With all this news about AI, have you ever thought to yourself, will everything now use AI, or should it even? And well, the answer is probably not. But how to think about when AI actually makes sense and when it doesn't. If you've been thinking about similar questions, then this talk is for you. So first, to help you navigate through the hype around AI, I will show you my framework of how I make sense about when Gen AI makes sense for a use case and when it doesn't. And second, you will get a deep look behind the scenes into how we're using Gen AI at GeoSci to produce location descriptions for neighborhoods. So yeah, as I was already introduced, I'm Florian and the founder of GeoSci. So what we do at GeoSci is fundamentally help people find the right locations. Yeah, so think home seekers or travelers, for example. And we're a B2B2C company, so our analytics usually go into customer-facing products at our customers. And we have a few solutions that support our missions. So number one is place analytics. So these are numerical ratings that are supposed to answer any question that people have about a location. So for instance, is it quiet? Is it wheelchair friendly? Is it safe? Can I buy all I need? Or even can I charge my car there? Then on top of this, we also do heat maps to help people make sense of an entire area quickly. So imagine you're looking at a map of Airbnbs and you want to quickly figure out which ones are well connected to public transport and which ones are not. Then we do a little AI consulting as well. So we help other companies launch the right products more quickly. So here you see Lena, my co-founder, giving a workshop. And lastly, and of course, this is the focus of today, we are doing quite a bit in AI as well. So these are mainly two products. The first one is an AI location guide. So imagine a knowledgeable assistant you can ask about any questions regarding a neighborhood. So for example, can you suggest a great Thai restaurant within 10 minutes walking, and it should be in a safe neighborhood? Or, and this is the focus of this talk later on, area descriptions. So these are detailed texts which describe a neighborhood for home seekers or for travelers. Now, before I dive into the talk, let's discuss some key terms that I think are often misunderstood and that are pretty important for understanding the discussion later. Number one is ML, machine learning. Yeah, so that's a model basically that has learned correlations in data and can make predictions. So for example, you want to predict the number of cars on a street given the size of that street. And when I talk about ML, I mostly have a specific image in mind of models that are quite small, that I train myself, usually on my own laptop, and that normally produce structured output like numbers or categories. Then, of course, LLMs, which are a subset of ML. LLMs are very large and focused on human language. And I usually use LLM, AI, or Gen AI quite interchangeably. And an example of an LLM, you've heard that before, is GPT 3.5 or GPT-4 Turbo. And you don't train, or you don't tend to train LLMs yourself. At most, you fine-tune them with your own data. And LLMs, we've also heard that, are very large, very costly, both to run and to train. So, for example, it costs, I think, over $100 million to train GPT-4. So, and number three, an algorithm, simply a defined way to turn inputs into outputs. An example would be a function which takes two numbers, adds them, and then returns the result. And the key difference between a statistical model and an algorithm is that for an algorithm, you always know what a given input will produce. So they're deterministic. Now we're all set, so we can get started with the question, when does Gen AI actually make sense? And maybe this rings a bell. There is an increasing focus by top management on AI, so some of your meetings may look like this. I hope not too many. And this is putting the cart before the horse. Here the point is, we must use Gen AI, find me areas where we can do that. And I'd argue this is wrong. The reason for this is that AI cannot give you a competitive advantage. The most powerful models are accessible to anyone with a basic laptop, an internet connection, and a credit card. So just using AI for the sake of it does not make your product or your business special. There's a great post which elaborates that point more in detail, called AI is like water, which I've linked in the footnote. So coming back to that AI coffee machine from the intro, I'd argue that making a perfectly good product smart is a bad idea. Yeah, it just makes it more expensive, unsafe, and error-prone. So to assist you for such kinds of discussions, I'd like to give you a framework for thinking through when AI does actually make sense. Now, this framework that I'm introducing here has two dimensions. The first one is strategic fit, and the second one is feasibility. And the guiding question for the strategic assessment is, can you use Gen AI to support the areas where you create value for your customers or your business? And for this, you need a deep understanding of both your business and the possibilities of AI. So on the one side, that's business analysis, to understand why is your company successful? What contributes to the competitive advantage of your business right now? What are your challenges? What are the special ways you delight your customers? Where can you be more productive or efficient? So a great book on this, it's Richard Rommel's Good Strategy, Bad Strategy, which I can highly recommend. And you connect that analysis to thinking about AI. What is now possible that wasn't possible a year or two ago? And what are the limitations? Where is Gen AI struggling with? And the ideal outcome of this analysis would be a clear view for a particular use case on whether AI can make you more competitive, tailored to your particular circumstances. And you can even check your result. Would this objective also be a good idea without using AI? If the answer is yes, then this may actually be a good idea. Now, the second level of the assessment is regarding feasibility. is GenAI a good candidate for a particular solution? And here I have 4 different levers that I think are important. Number 1 is the data type. So GenAI is perfectly suited for unstructured data. So think text, of course, but that also includes images, video, any data where you don't have a clear structure. On the other side, if you do have a structure like tabular data, for example, think of a spreadsheet, then maybe an algorithm may be a better solution compared to an LLM. Number 2 is accuracy. I think this was one of the focuses of David's talk from before. So GenAI, as I explained earlier, is based on using a statistical model. So statistical models, on the one side, they can hallucinate, or they can also just simply not say something that may be important for answering a particular question. If you need 100% accuracy, then quite likely GenAI may not be the best solution. Latency. So using a large language model, especially the most powerful ones, just takes time. You know it yourself when you're using ChatGPT. It sometimes takes 10, 20 seconds or even longer until you've received the complete answer. So if your use case requires very high speed, then again, an algorithm may be the right solution. And lastly, predictability. So a LLM is a black box. We don't know, given a particular prompt, what the result that the LLM returns is going to look like. And even for the same prompt, if you give that more than one time, you do not know that every answer is the same. Even if you set the temperature, so that's sort of a randomness factor of the model, even if you set the temperature of the model to 0, still the same prompt may produce a different answer when you ask it again. So that means if you need to know in advance what your particular system is supposed to produce, then again, you need something deterministic like an algorithm. Good. Now, having a framework about how to evaluate AI, let's apply it to a concrete solution. And then afterwards, let's look at that solution in depth. So the example that I'm taking here is the AI written area descriptions. So what I'm showing here is just the beginning of one regarding the area where I live in Hamburg, Hamburg-Eidelstedt. You don't need to read this. This is just to give you a picture of what the product looks like. Now let's use the framework from before to think this through. Does it make good business sense to create location descriptions using AI? And let's start with the strategic assessment. So on the one side, I'd argue this is based on our mission. We want to help people make sense of locations, understand if this is the right place to live or maybe to go on vacation. So creating accurate location descriptions is something that fits well with what we're doing at GeoSci. And second, it's just simply impossible to do this without AI, because we're talking about potentially more than 100,000 location descriptions that we're creating for our customer. And those location descriptions also need to be updated on a regular basis. So this is simply not something that humans could do at that scale and given the budget that we have. And lastly, is this something that actually differentiates us in the market? Is this something where we have some sort of defensible position and moat? And I'd argue the answer is yes, because of all the local ratings, of all the place analytics we do, and the data that we have access to, we can write much better location descriptions than simply another AI company that would not have those assets. And now regarding feasibility, let's start with the data type. So the input is sometimes text, yeah. So let's say text data from Wikidata, for example, an open source project, and it's of course also our local ratings. But we don't just pass numbers to the LLM. We first transform them into concrete evaluations. So, for example, we're not saying quietness of that area is 90%. We would say the quietness of that suburb is very good. So this is something then that the LLM can work better with. And also the output is quite unstructured. Yeah, we're asking the LLM to produce text, these descriptions. We ask it to write them in Markdown format. You've seen that before, rendered. So that makes them look nicer. So it's not completely unstructured, but LLMs are actually quite good at producing Markdown. With regards to accuracy, you see the star is pretty much on the right, because in the end, we want those descriptions to actually help people select. Yeah? So they need to be right, and they also need to contain the types of places that we think are important for people to make sense of an area. And this is one of our main focus areas. How can we engineer our prompts? How do we need to pass helpful input data into the prompts? How can we maybe iteratively have the model reflect on its output to make sure that the final result really is true, that we have as few errors in the texts as possible. Latency, luckily this is good. This is not a user-facing system here. It's a job that runs in the background. So the production of one area description takes sometimes up to 1 minute, 90 seconds, which would be unacceptable for a user to wait for. But in our case, this is fine. So this is a good use case for an LLM. And finally, predictability. In the end, we don't really care how the resulting text look like. We just want it to be correct and contain some important facts about the area. So predictability does not have to be very high. So I'd say, yeah, this is a good use case for an LLM. Okay, now let's dive into the solution itself and how we're using AI components throughout the process to create those descriptions. And I'll take a location description for Hamburg-Eidelstedt as the example here. So maybe the first question you might be asking yourself is, why can we not just directly ask the LLM to write a text about the location we're interested in? Dear GPT, please write a location description about Hamburg-Eidelstedt. Well, unfortunately, this doesn't work, and you may already be thinking about why. The reason is simply that the model would likely invent places that aren't in Eidelstedt and also not mention important facts that we want home seekers or travelers to know about. So the important problem we're trying to solve with this entire pipeline that I'm going to show to you in a second is accuracy. We want the final text to be right. And the very first step of that data pipeline is a loading phase. So we're taking all the location related data that we have access to for the area that we are querying, in that case here, Hamburg-Eidelstedt, and use SQL and take that data out of our database and load it into our Python app. Then the next question is, given that large amount of data that we have loaded into the system, what is now actually helpful for producing a location description later on? And this is what's happening in that step. And here we're actually using GenAI to make the selection, so that we only pass on the pieces of data that are helpful for generating a description of Hamburg-Eidelstedt. And in the next slide, I will show you this step a little more in detail, what's happening under the hood. Now, given that we have selected all the pieces of data that we need to produce a location description, this step here is a summarization step. So we're condensing all the data and make it very focused on what home seekers and travelers really care about. And this has two reasons. The first one is that later on we will use that area data and include it into the final prompt that will go to the model, which will be asked to produce a location description. And you may have realized this when you're using ChatGPT. The shorter, the more focused a prompt is, the more likely you will actually get the correct result. So we're trying to really focus this area information on what's vital to understand the area. And the second reason is, of course, also cost. The shorter the prompts, the less we pay to OpenAI. Then here in that step, we take the area information, the condensed area information from before, and we put it together with the entire prompt that, for example, says, please be accurate in creating a location description. Don't try to sell the area. Please don't write about anything that's politically sensitive. This is the sorts of instruction we are talking about here in that step. And this complete prompt then goes to the text generation step, which has two sub-steps. The first one is where we're using a powerful model, so GPT-4 Turbo, to produce a base location description based on all the data from the prompt. And afterwards, once that location description has been created, if the client has requested it in a couple more different languages, we just use GPT 3.5 Turbo to translate the base description. So GPT 3.5 Turbo is good enough to do that, and the result is much quicker and, of course, also more cheaper. Okay, now two more comments on that data pipeline. The first one is, what is, of course, critical in such a pipeline is that in each step, you know exactly what data type comes into that step. And you also need to know what type of data you're passing on further downstream. And this in the past used to be a challenge of LLMs, which in the end produce text. But nowadays, with function calling, which is a somewhat more technical concept I have not yet introduced, but the developers among you maybe know that. So with function calling and libraries like Instructor, you can quite reliably make models return text that can be put into a particular schema, like a JSON schema that you then can parse and make sense of in a downstream step. And the second comment before I move on is, why are we using these LLM components in the first place? Why do we not put everything into one single big prompt? Well, fundamentally, for the same reason why we want to have small units of code anywhere, the single responsibility principle. So each smart component should work separately, which makes it much more easy to reason about. It makes it more reliable, more easily debuggable, and especially easier to test. So as LLMs are black boxes, testing the output after any change is crucial to make sure that you have not introduced any bugs. For example, recently I just entered one more new line into the prompt, and the resulting descriptions were completely different. And you don't want that. You want to make sure that after every change, you test what the model will be returning. Now, let's go one more level in depth and look at the select step. So here the job is to take a long list of texts that somewhat relate to an area and filter out those texts that may, for example, describe the suburb nearby. Yeah? There may be a text that we found in our SQL query, which was about Hamburg-Lurup and not Hamburg-Eidelstedt. So we don't want that to be passed on downstream because it may then confuse the model later on when we ask for the area descriptions. And this works like this, that on the one side, we are giving GPT-4 the name of the area that we're interested in, and also the article titles and a couple of sentences for each article. And then based on that information, the LLM can decide what of those article titles actually contain or likely contain information that is helpful for describing that particular neighborhood, and which articles may not contain that information. And then it can filter out those articles that are unhelpful. And the result of this step is then a more focused list that the pipeline can work with. Now, we've gone quite deep. Let's go back up and look at the big picture again. Should you transform your company based on a dog poem? Well, sure, if it supports your business strategy, if it's actually feasible, given the constraints that LLM work under, and if you find a good architecture for your system. For example, these smart components that I described earlier. So this may be then a good framework to help you decide, should you use GenAI for a use case or not? If you just transform unthinkingly, if you just listen to the boss in the meeting, at least according to ChatGPT, this is what may happen. ChatGPT's nightmare here. Who knows, maybe that smart coffee maker. Okay. Now, I'd be super curious about your questions, what you would like to know. And I would also be very interested to hear where you are in adopting GenAI in your product, in your team. So if you like, you could just scan that barcode here and answer the one question survey. And then I can share the results in a moment, and we all see how far we each are in adopting GenAI. Thank you.
All right. Thank you, Florian. While we're waiting for everyone to fill in the one question survey, I'll jump with the first question that I had, and then we can jump with some of the questions from the comments. I found it very interesting that you kind of constrained or restricted the input data in order to increase accuracy. That's kind of like trying to make the best of both worlds. I thought that was really great. My question, however, is more kind of piggybacking on what David talked about in his presentation as well. Were there any compliance or legal hurdles that you had to overcome? I realize that you're working with clients, and normally, in most cases, it's the client's data that you're using, right? So in theory, there shouldn't be any issues, but was just curious when building whether you had any issues on that.
Yeah, sure. So what we're doing is we have to make sure, of course, that the texts we produce, that the licenses of the different pieces of data that we use to create those texts are compatible, which is not easy sometimes because let's say Google, for example, has a very restrictive license. So we're not even using Google Maps data because otherwise we could not combine it with any other data. So we're mainly focusing on data that's in the public domain, plus whose license is actually set up in a way that it can be combined with with other pieces of data. So yeah, you're absolutely right. This is a big challenge.
Thanks for that. Do you want to go to the results before we jump into the other questions?
Sure, let's do that. Okay, we have received only 2, I think. So trial and proof phase. I'll go back to the other slide. People who are still listening and have not responded yet, maybe you can get.
Yeah, let's go to the other, and maybe we check after all the questions. Then let's take the questions from the comments. So the first one is from Alex M. What emerging trends in AI do you see as most promising for the future of geographic analytics?
Okay, there are 2 levels, right? What are the trends, and with regards to geographic analytics? I'll start with geographic analytics first. So I think fundamentally, what makes AI solutions systems work well is if they have access to great data. Yeah, because we are talking about so specific data that's geolocalized, that the training that the model has received based on what's available in the internet is not good enough. Yeah, if you just ask ChatGPT what's the distance between your home address and work, you won't get a good result. Yeah, so you need to provide the right context, the right data to an LLM. And there has been one very exciting new data set that's basically a fusion of the data from, I think, TomTom, Amazon, Facebook, and they've open sourced it. So it has a pretty permissive license, which is great. It's called Overture Maps. So I find that very exciting because it will, for areas where we may not have so good quality data, it will still enable us to use that to try if maybe it could fill gaps in the data sets that we're currently using. And now regarding the future of AI, of LLMs, I think, 2 trends. The first one is fundamentally about improving accuracy. So there's one interesting design pattern called reflection, where you ask maybe another model to reflect on the previous model response and give feedback. And based on that feedback, the first model can then again iterate and improve the first result. So I think this is quite exciting. To just increase the likelihood that the texts, for example, here are right and that they also contain the right information. So this is something we're experimenting with. And the second interesting trend, I think, is regarding actors, so that you don't think of an LLM as one big model that's doing everything, but that you think of LLM more as, let's say, a system that contains different agents. And if you ask maybe the coordinating agent a question, give it a task, then that coordinating agent can give smaller subtasks to all the other agents in the system, which can work in parallel and then return the results of their analysis back to the coordinating agent, and that agent can then back respond to the user. So this is one big trend that's currently ongoing, and that I find also quite exciting to work with.
That's really something. At least for me, the first part of having another model to kind of coach the first model, that's really something. Good. Next, let's jump to the next question, and we'll take we'll take 1 or 2 more. So are there, from Fayaz, are the location descriptions in the end manually reviewed? If not, how do you ensure quality? Are you also taking liability of the information provided?
Yeah. So are they manually reviewed? No, they're not. Of course, we're not saying we now launch 100,000 location descriptions into the world. There are a couple of steps that we go through. And the first phase of this project that we're in right now is that the team of our customer has generated maybe 100 descriptions, and they're looking at those descriptions in detail, and they're giving us feedback how they would maybe want the tone of voice to change, what information should be there, what information should not be there. Based on that feedback, we then do the next iteration. We will then run a test probably in 2 different states in Germany, where we then maybe create 1,000 location descriptions, put that live, see how users react, if they find it helpful, what feedback maybe real estate agents give us regarding the texts. Once that phase has completed successfully, we do it for the entirety of Germany. And again, if this works well, there are, I think, 25 more countries waiting to be described. So that's then the future. And no, we are not taking liability. We cannot take liability for this. This would make it impossible for us as a startup to do this in the first place. So, I mean, it's the same way that ChatGPT does not take liability for its output, because in the end it's a statistical model and you can never be 100% certain that the text will be correct.
Understood. I also I imagine that just coming back to the coach for a language model, there could be, or there might already be language models out there that could post descriptions, for example, or equivalent to a forum or a question site like Quora, and maybe evaluate to what extent it was upvoted or downvoted, right, or criticized, and kind of like not hijack, but hack the learning or the feedback. All right, good. Next question from Isaac. I was traveling in Barcelona. It was late, rainy, and getting dark early. Is there a plan to use all information to provide real-time recommendations or trips, considering the weather, opening times, and the likes?
Yeah. So as I said in the beginning, we are also creating this AI location guide, and we still need to figure out what should be in scope and what should be out of scope. And this is a big question, because at some point it will be just another ChatGPT with maybe more skills. So we wanted to be more focused and really be focused on areas, maybe with the use case of home seekers and tourists. And yeah, I think what we're going to do is speak to lots of users to understand what are the main questions that they have, and on the other side, think about what we are good at, what are the place analytics that we can produce, what are the points of interest that we have in our database, what other APIs can we maybe integrate, and then in that discussion come to a solution, what we will finally release. So I don't know it yet exactly what this will look like.
Makes sense. All right. That was all the questions. I do have one last one, since we are talking about applying Gen AI, right, in products, and I think David touched a bit on this, but I wanted to ask you as well. Can you talk a bit about how you actually validated or discovered the market fit for this particular description composing, right, or generation?
Mm-hmm. Yeah. So fundamentally, we are in contact, or I'm speaking regularly to leaders at real estate firms and platforms. So we talk about what their strategy is, what their priorities are, what they're thinking about. And one topic that came up repeatedly was this problem when people, for example, post an expose, when they create a listing, that they struggle with creating the location description, because it requires a bit of research. You need to make sure you get it right. Also, it needs to be up to date and so on. So there the thought was, okay, why can we not use Gen AI to do that and help people putting their properties online? So that was the expose location texts. And then here these large-scale area descriptions. It was in the end then a good coincidence that one of our large customers said, we are looking to describe all the areas where we're active in. This is impossible to do manually. Given that you know how to create these expose location texts, could you help us with our project? And yeah, sure, this was something we had not done before, but it was quite well related to the existing solution. So it was not like a custom development, which would have taken us many months to do from bottom up. We could use a lot of the knowledge and the code that we had already released. So based on that, we thought that's a great way to make sure that this customer is happy and that we can really help them with that project. So this was a bit the thought process behind.
Thanks for sharing. All right, shall we see the replies before we go to the closing?
Let's hope there are some more now. Okay, we have 4. Okay, I guess this is not really statistically significant, I would say, but that AI in production value proven is only 25%. So that we are still some way, and I think this connects with what I hear in the industry as well. That many people are trying POCs. There are people playing around with Gen AI, but it is not so often that it's actually live in production and that it's creating value. So I think this is not surprising.
Yeah, and I think to some extent, at least right now, for a lot of models, the biggest kind of value creation is in relation to time, right? That you can actually get something with a lot less time spent at scale. And time reduction. So it's less on actual value creation or generation, just like what was mentioned initially, right? Like if you want to create something or generate something, right, there's more legal issues in there, particularly when you have to kind of provide or get your own data, right, and not use someone else's.
Yeah.
All right. That was it, and I thank you again, Florian, for also for joining and for sharing with us a bit about your journey and GeoSci's journey. And as with David, feel free, everyone, to reach out to Florian to find out more and any other questions that you might have.
Sure.
And with that, we come to the end of today's ProductTank session. As mentioned before, do reach out if you want to talk about hosting a ProductTank edition, or you want to speak, or you just find or are interested in a particular topic. And we're here to actually support the community and organize the events for you, either online or in person. Yeah, with that, we thank you all for the attention, and also everyone for the questions and for being active in chat. And with that, I was looking at I was wondering why you're moving, Florian, but I was watching the stream, which is delayed, so joke on me. But with that, I wish you a crazy evening, the good kind of crazy, and we'll see you in the next meetup. Thanks, everyone.
It's fantastic. Thank you very much. Goodbye.
Bye.